Okay, this is 8, 4. The warm-up, no negative exponents and no hanging exponents. So we're just going to start and simplify it. 49 over 7, normal numbers, treat them normally. 49 over 7 reduces to 7 over 1. 4 A's on top and 1 on the bottom leaves me 3 on top. 7 B's on top and 4 on the bottom again leaves me 3 on top. 2 C's on top and 3 on the bottom leaves me 1 on the bottom. Now we're done. Hopefully these are getting a little bit easier, coming a little bit faster. All we have to do today is we have to look at polynomials, so multiple terms. We have to find the degree, which is like how strong it is, and we have to put them in a specific order, so no calculations. So polynomial is multiple terms, okay, so multiple monomials put together. If there are 2 terms, then we call that a binomial, and if there are 3 terms, we call it a trinomial, and then anything 4 or more is just poly. Okay, so if I have, remember 2, so 5x, y, z, no addition or subtraction signs, that's a monomial. Okay. If I have 2x plus 3y squared, that has a addition sign, so that splits it into 2 pieces. So that is a binomial, like a bicycle has 2 wheels, a binomial has 2 terms. If I have 5x squared plus 2y to the third minus 7, that splits it into 3 pieces. Okay, so that's a trinomial, like a tricycle has 3 wheels. Okay, and then 4 or more is just poly. So if I have like 12 plus 3y squared minus 7x plus 2z. 1, 2, 3, 4 pieces or more is a polynomial. Okay? All right, to find the degree, you add the exponents of the variables only. So this is a monomial because there aren't any addition or subtraction signs. -2 is a normal number, so to find the degree, like how strong the term is, I don't care about the normal number, I only care about the variables, and I care about their exponents. So the exponent on this x is 1. So I'm going to take the 1, add it to the exponent of the y, which is 2, add it to the exponent of the z, which is 3, and 1 plus 2 plus 3 is 6. So this is a 6th degree monomial because it's only 1 term. I didn't have any addition or subtraction signs, so that's mono. And then 6th degree because I added the exponents of the variables and got 6. Okay, for the polynomial, you do the same thing. You find the degree of each individual term, and then the biggest one wins, okay? So terms are separated by addition or subtraction signs, so we split them up. Go to each one separately. Normal numbers don't count, just the exponents on the variables. So 2 plus 2 is 4. Normal numbers don't count. My only exponent is on the x is 2. Normal numbers don't count. I don't have any variables here, so this one doesn't have a degree at all. No variables, 0 degree. This is where most people get stuck, so be careful. Just look at each one separately. The biggest one wins. So my biggest one out of all these was 4. So that's my answer. It's a 4th degree. I don't smush them all together, just the biggest one wins. So 4th degree, and then you have to name it. We had 3 different pieces. 3 is trinomial. So that is a 4th degree trinomial. Okay, we're going to go through these pretty fast. Put your squiggles on any addition or subtraction signs and find the degree of each thing. term. Normal numbers don't count. This doesn't have any variables, so that degree is 0. B is a variable, its only power is 1. 6 doesn't count. 1 plus 1 gives me 2. 8 doesn't count. 1 plus 2 gives me 3. I look at all of them and I find the biggest. My biggest one was 3. So this is a third degree. And then label it. How many pieces do we have? We have 4 pieces. Anything 4 or more is just poly. So this is a third degree polynomial. Okay? There aren't any addition or subtraction signs here. So you just find the degree. Normal numbers don't count. 2 plus 5 plus 1 is 8. That was the only term, so this is just, it gets to win. So it's an 8th degree. And one term is monomial. Okay. Last one. Put your squiggles on any addition or subtraction signs. Find the degree of each. Normal numbers don't count. A is just to the first. No 7. 1 plus 1 is 2. No 2. 2 plus 1 is 3. 16 doesn't count, and it doesn't have any variables, so that one's 0. Biggest one wins. What's biggest? 3. So this is a third degree. And then you have to label it. It had 4 pieces again. 4 or more is poly, so polynomial. All right, the last thing we have to do is we have to put them in order, okay? We are going to practice putting them both in ascending and descending order. If you aren't given a specific, then you usually put them in alphabetical descending order, but we'll talk about that. So think about ascending. If you're going to ascend the stairs, you're going to start at the bottom, and you're going to work your way up. So you have to start at the lowest power and go up to the highest. If you're descending, then you start at the top and work your way down. The other thing is you have to have a variable that you have focused on. You have to be told what variable to put in ascending or descending order. So this says, that you need to put the powers of x in ascending order. So specifically x, and ascending means you start at the bottom and work your way up. So you're going to put your squiggles on with any addition or subtraction sign. And you are going in ascending order, so you have to start at the bottom. So which of these pieces has the fewest number of x's? Well, the negative 11 doesn't have any, so that one gets to go first. So negative 11 goes first, then I'm done. 1 after the next highest one, or the next lowest one is 2, so then I'm going to put a positive because it's positive 7x squared. And then my last one is a positive 2x to the 4th. So if I look, my powers of x go from 0 to 2 to 4. I'm ascending. I'm climbing from the bottom to the top. I think I fixed this in yours, but this should be squared. Okay. Put your squiggles on any addition or subtraction signs. And now, we have x's and y's, but they told us to focus on x's. So I need to look at all these terms and find the one with the least number of x's. Okay. This y squared doesn't have any x's, so it gets to go first. It's my smallest. It's positive, so positive y squared first. I'm climbing up, so which one has the next fewest number of x's? My first term here only has 1, so that's going to go first. It's positive, and it's a 2xy to the 3rd. The next fewest number of x's is the last term with 2, and it's minus, so minus 3x squared y. And then finally a plus 5x to the 3rd. Look at your powers of x's. We go from no x's to 1 to 2 to 3. You're climbing up the stairs, ascending. Okay? And you're done. These are powers of x, again, in descending order. So you start at the top and work your way down. This is normal. This is what we will normally do. If you're not told specifically, you usually go descending order. Okay, squiggles on any addition or subtraction signs. start at the highest. So where's my highest power of x? Is that x to the third? It's negative, so negative 2x to the third. Then which one has the next most number of x's? Is the 6x squared, and it's positive. Then just the minus 8x. And finally, the plus 5 doesn't have any x's, so it has to go last. So we go from 3 down to 2, down to 1x, down to no x's. So you're descending. You're starting at the top and working your way down. Squiggle, squiggle, squiggle. We are still going by powers of x, so ignore the a's altogether. We need to find our highest power of x. This one has 5, so that's going to go first. So positive 4a x to the 5th. What's our next highest power of x? This one has 2, so that's next. So positive 3a squared x squared. This one only has 1, but that has to go next. So plus 9a squared x. And then finally, this minus a to the 4th doesn't have any x's, so that's last. So minus a to the 4th. So then you look. You go from 5 x's, okay, to 2, to 1, to none. You're on your way down, descending order. Okay, 8.4.